And we are live, you guys. It is April 1st, April Fool's Day, but this is no fool. We actually are going to do some things today. So, first of all, here's my little agenda. So, before we go too far, let's take a look at the homework sheet. So, this is from the last chapter. Let's go. Okay, so if you are in good shape, awesome. All of these grades are going to go in the grade book. If you are not and you need to get your tests or quizzes in, get your test in, okay? It needs to be done by Friday, okay? Hopefully you are doing chapter 6 homework. I've been keeping track of that, but some of you guys are on top of that. Chapter 6 looks kind of like this. So some of you guys are doing chapter 6 and some of you aren't, so we got to get on that. I'd like to give a quiz on Friday. So, and then spring break. When spring break comes, which is coming this Saturday, you're free, okay? No work, no lessons. Spring break, you are free. I don't know what the heck we're going to do. Can't go camping, can't go anywhere, but you know, I won't be teaching. I won't be giving lessons. There will be no homework at all, okay? So, starting Saturday, nothing. But this Friday, you have a quiz, okay? So, and then we'll come back on that Monday. I think it's the 13th, because it's Monday, April 13th. We'll come back. I'll write that down. Monday, April 13th, we're back with lessons, okay? But you can take break off. I won't record. There'll be no homework assigned, okay? So now, let's take a look at yesterday's homework. I want to talk about that briefly, and then we'll look at the lesson, okay? So here is yesterday's homework. So the easiest way to do these is to graph them. And so when I graphed, I did a really rough graph. But you see that J shape? Looks like a J. Kind of curves up exponentially. So if I were to try and connect the dots, it looks like that. That's definitely growth. What I'm doing each time is multiplying by 1.5. If you, and we got to talk about this today, if you're not sure what it's growing by, take the second one and divide it by the first one, and you'll get your multiplier. I'm going to talk about that again today. This one, if I graph it, it looks like it's going down. It does look like decay again. If you're you want to figure out how to get this, you take your second one, which would be like 40, divided by 160, and you get 1/4, and that is decay. When I graph this one, it looks straight, so it is linear. It looks like I'm going down by 10, down by 10, down by 10, so that's what makes it linear. 5 is growth. Again, if you graph it, you can see that kind of shape. If you want to know what the growth rate is, what the multiplier is, again, you take the second one and divide it by the first one, and you get 2.5. So you're multiplying by 2.5, 2.5, 2.5, okay? 6 is easy. If the multiplier, if B is less than 1, it's decay. If B is greater than 1, it's growth. If B is, take 3/4 of something, it's going to get smaller, it's decay. Now 9. So we didn't talk about quarterly or monthly. So you probably have this, 3,000 times 1 plus 0.06 to the t. That's fine for right now. But if you want to do it quarterly, you have to divide it by 4, because that's 4 months. It's 4 times a year. And then you multiply by 4t, because you're going to compound it 4 times a year. Monthly, you probably have this. And you're going to go 1 plus 0.072 to the t, and that's fine. To make it truly monthly, you're going to divide it by 12, because you're going to divide it in 12 months, and you multiply by 12 up here, because you're going to go ahead and get money 12 times in a year. We will probably stick to this. Quarterly and monthly we won't deal with until you get into Algebra 2, but right now we're just going to look at it. Okay, so that's your homework. Hopefully you guys will get that into me. Hopefully it's somebody bringing me homework into my phone. So, what about today's lessons? Okay, so let's talk about today's lessons. So you're going to need graph paper for sure. And what I'm going to do is show a couple of things to you, okay? So, get my lessons out here. I have everything. Yes, I do. Here we go. So, today's lesson is just telling whether or not something is going to be exponential or linear. So it's kind of easy. You can see in this one, it has that shape. It's going down, it curves, it's getting smaller, smaller, smaller. So this one's going to be exponential decay. Again, if I want to find what it's decaying by, what the rate is, you can take any y value, y2 divided by y1, which would be, in a sense, let's see, 4 I'm going to have 4 divided by, so I'm going to go 2 divided by 4, which makes, in this case, 1/2, so it's getting half as big. Okay, this sure looks like a linear to me. Linear is straight. Y equals mx plus b. We know that, so y equals, looks like it's going down 1 over 1, down 1 over negative 1 over 1x minus 1. Okay, and again, we don't need the negative 1 over 1. We can rewrite this as negative 1x minus 1. Okay, so it's straight, it's linear. Okay, we know how to find the equation of a line. The slope is down 1 over 1. Okay, now let's jump to, I'm not going to do 3, but we'll do 4 and 5. So to do it, what I'm going to do, and I'm going to require you to show your graphs, is I'm going to graph this. So on number 4, I'm going to get out my graph paper, and these are the points I want to graph. So I'm going to graph negative 4, negative 2, negative 2, negative 1, 0, 0, 2, 1, and 4, 2. So I need you to graph these, because the best way, it might take a little bit more work, but the best way to know what's going on is to see a picture of it. Okay, so let's do this. Alright, and again, you can pause the video anytime you want. Okay, and I'm going to go ahead and put the points in. So let's see, I'm going to have a point at, so we're not doing 3, negative 4, 1, 2, 3, 4, negative 2. Okay, I'm going to put a point at negative 2, negative 1, 0, 0, 2, 1, and 4, 2. Boy, it sure looks like it's a straight line to me. Indeed, that looks linear, doesn't it? Okay, so if I think it's linear, which indeed looks like it, I'm going to use the equation. We're going to use y equals mx plus b. We know the slope is up 1 over 2, up 1 over 2. Y equals up 1 over 2x plus 0. And again, no, you don't need the plus 0. It's an invisible 0, but there it is. Okay, that's number 4. How do I know it's linear? Looks as straight as can be. Looks like a nice straight line. So the slope is up 1 over 2 all the way through. Okay, now let's look at 5. So 4 should have been easy. Okay, let's look at 5. Okay, number 5. Again, I'm going to graph these points. I'm going to see what it looks like. Let's see, on number 5, I'm going to have a point at negative 3, negative 9, okay? 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 2, negative 6, 2, negative 2, 1, 2, 3, 4, 5, 6. Negative 1, 3, negative 1. Really, negative 1, 3. I'm going to jump all the way up to there. Negative 1, 3. Wow. 0, 2. And 1, 3. Is this right? Negative 3, negative 9. Negative 2, negative 6. Negative 1, 3. Now that one just seems bizarre, doesn't it? And then a 0, 2, and then a 1, 3. What? Well, I've got to say that's neither. Don't you think so? Okay, I'd say that one's neither for sure. Crazy, huh? It's all over the place. Okay, now, let's look at one that is exponential. Okay. Alright, so let's look at number 6. See what's going on with 6, okay? Alright, number 6. Go ahead and draw in my graph. Oh, I could do it this way so you guys can see this way. No, I like it this way. I do like it this way. I do like it this way. So I'll turn it upside down so I don't waste graph paper, okay? Alright. Number 6, I'm going to go ahead and draw my XY axis. I'm going to graph it. See what it looks like. Alright. I'm going to go negative 2 and 1/4. And that's about there. Negative 1 and 1/2. It's about there. 0, 1, 1, 2, 2, 4. Okay, this one looks like it's exponential to me. See how it's curving up? Prior to connect the dots, it's got that shape, right? Almost looks like a J, right? So my equation is y equals ab to the x, okay? Now, here's where you got to pay attention. The a is always going to be the y-intercept. So your a is your y-intercept, or some 0, comma, some number. We'll call it c, okay? Well, in this case, it's got to be 1, okay? 0, 1. So my a in this example is 1, because I've got a point at 0, 1, okay? I need that. So wherever this is, whatever my y-intercept is, that's the value of a. That's my starting amount, okay? Now my growth rate, or my b, is going to be really my second y value, y2 divided by y1, okay? So y2, let's see, y2 is my, I'll take my 4, actually I'll take my 2 and my 2 and my 1, okay? It doesn't really matter, but you take my second y value, my first y value, okay? So y2, and you can pick any, I can take 4 over 2, I can take 2 over 1, but 2 over 1 seems easier. So if I take my y, so I've got these points of 0, 1, and I've got a point at 1, 2. Any 2 points together, okay? And to divide 2 by 1, my growth rate is 2. And it seems like it's that way. It seems like if I look at the point, multiply by 2, times by 2, times by 2, times by 2. But you can always get that. We call it r. We can always, nope, I'm sorry, let's keep calling it b. We can get b by either 4 divided by 2, or we can get b by 2 divided by 1, or we can get b is, believe it or not, 1 divided by 1/2, but we always get 2 over 1. Okay, so that's my b. So here's my equation. Y equals 1, that's my a. I'm going to go 1 times my multiplier, which is 2 over 1, or 2 to the x power. Okay? Now, last but not least, I have a story problem. Okay? Let's take a look at the story problem. Okay? Okay, number 7. Okay, the table shows the demand of a certain commodity where X is the number of months of the year. Okay, so, alright, commodity, it could be just something like, I don't know, something you would buy. So let's take a look at this one. Let's see if we can do it. So let's first of all, let's do a graph. Boy, it's going to start at 512, so I'm going to have to probably make my graph go way up to 512. Number of months, so the first thing I'm going to do is just make a scatter plot of it, okay? It doesn't have to be perfect, I just want a general shape of it, okay? So I'm going to put my demand, and this is in thousand, so demand, it's like the y value, so it's my x, my y, and my x's are going to go from 0 to 5, okay, 0, 1, 2, 3, 4, 5, and these are months, okay? Demand, I'm going to go up to 500, so if I go 100, 200, 300, 400, 500. Okay, if you need to pause the video, go ahead to catch up. Okay, and this is in terms of thousands. Okay, so for instance, 512 is 512,000, 256,000, 128,000, 64,000, 32,000, and 16,000. Okay, so let me do a scatter plot. So 0 and 512. It's about there. Doesn't have to be perfect. It's about there. Okay. 1 and 256. 1 and 256 is maybe right about there. 2 and 128 is maybe right about there. Okay. I don't have to be perfect. I'm just going to do a scatter plot. 3 and 64. 3 and 64 might be there. 4 and 32 might be there. And 5 and 16. Okay. So it definitely looks like it's exponential. And it looks like decay because it's getting smaller. Exponential decay for sure. So, now I need my equation. Y equals AB to the x. Okay, I need that equation. I know the value of A. The value of A is right there. Okay, where it starts, okay? So the value of A is at the point 0, 512. So A is 512. There's my A. B, to find B, I'm going to take any value, second value, and divide it by the first value. So I'll probably take, gosh, I can take any of them, right? So probably those two. Oh, let's do these two, what the heck. If I take the second one, 256 divided by 512, it reduces to 1/2. Or if I take 16 divided by 32, it's 1/2. So it is decay, and I don't know if you can see it, but it looks like it's going half of it, half of it, half of it. So that's my B. So my equation is going to be y equals this AB to the x, but I'm going to go y equals, I know A is 512 times 1/2 to the x power, okay, because that's my decay rate, okay? Got it. Now, so August, let's see here. So August would be the, oh, let's see, what is August? The 8th month? I think August the 8th month, right? So August, so finally C, we want August, and August is the 8th month. So I'll just let x equal 8, and I'll use my equation. So I'm going to take and plug in my 8 here, and I'm going to use my calculator. Okay, so I'm going to go y equals 512 times 1/2 to the 8th power. Please use a calculator, you guys, because you're not going to do this right. So I'm going to just put in my good calculator, and again, if you don't have a fancy calculator, you can load one up on your app. So I'm going to go 512 times 1/2 to the power of 8, and I get an answer of about 2. Wow. Only 2 items, huh? Boy, that's not a very good business. Sounds like they're going out of business, huh? So it's going to be 2, and it's in terms of thousands, so my demand is 2 or 2,000, because everything's in terms of thousands. Remember, it's in terms of thousands. Okay, so that's what I have for you today. Okay, for homework, I've got on 6-3, I want you to do page 171, 1 to 9 all. Okay, the first ones, you don't have to come up with an equation, just plot it. You've got to plot it and tell me what it is, whether it's linear, exponential, or neither. Same thing 2, 3, and 4. You don't have to get an equation, just plot it, show me the graph, and then tell me what it is. Okay, on number 5, okay, I would make a rough graph and tell me again whether it's linear or exponential, okay? It does not ask for the equation, but now on 7, you do have to write the equation, okay? So I would graph it, and then tell me the function, okay? And then 9, here's a little bit of a story problem, which I know you can do. Graph it, and they want the equation, okay? Tell whether the data can be by linear or exponential, okay? Okay, I will talk to you soon, okay?